Okay, so in that last video, we drew a line that fit the data best, but we were eyeballing it. We were just kind of guessing where it would land and where it kind of felt right. However, we want to be able to use technology to do this. So this is something that I won't necessarily test you on, but this is a good practice to have, and imagining these linear models within data sets. And like I was saying, if you've taken statistics or you're going to take statistics, this would be something that you do there. So I'm going to walk you through how to do this with Desmos. So what we would do, and I have our instructions at the top here, but I'll go through those instructions with you in Desmos, and we should basically end up at this screen here where we can see our data table, we can see the scatter plot, so we can see our points there, and then we're going to fit this line, so we're going to input this information here, and it's going to draw this line of best fit. And then with that, what we'll have is the slope and intercept for the line, so that we can make more accurate predictions. So let's go through those pieces. So we're going to go to the graphing calculator. So we're going to be here. There's this plus symbol in this upper left-hand corner, and that's where you can choose to add an expression, a note, all sorts of things. We want to add a table. So I can see my x1, y1, and what we're going to do is for x, we're going to input all of our x values. So 1990, 1992, and then, oh, I love this about Desmos, it gets the idea of the trend that you're following, and so since all of our years are going to jump by 2, you can just start hitting enter, and it will fill in those dates for you. And we want to go to 2008. Alright, so that's all filled in. And then for Y1, we're going to type in our values, just to make sure I do these correctly. 21.3. Okay, gonna type away, and then when I do this, I always double check that I've typed everything in correctly, because if one point is off, it'll throw the whole graph off. Alright, so with that, we have our scatter plot. Now notice over here, I don't see anything being graphed. I can't see my scatter plot. And that's because we're looking at x values 0 through 20 right now, and y values 0 through 20. I mean, we can almost see our y values, but notice x, we're way off, because we're out in 1990 to 2008. So what we can do is adjust the domain of our graph so that we can see our scatter plot. So there's this wrench symbol, and sorry, it's off of the screen that's recording right now, but in this upper right hand corner there's this little wrench. It says graph settings if you hover over it, and it's going to open up these options, which some things that can be nice is projector mode if you need to see things more clearly on your screen. That's a good option. So what I'm going to do is adjust the x-axis. I want to see from 1990 to 2008. I'm even going to go beyond that. I'm going to go ahead to 1980 up to 2018. Let's go to 2020. So now I can start seeing my dots. Awesome. But they're still kind of off the screen there. So what I'm going to do is the same thing that I did for the graph that we drew on paper, and that really these values are occurring between 20 and 30. So I'm going to adjust the y-axis to just look from 20 to 30. And then I'm going to close that down. So now I can see my graph a little more clearly. It looks a little bit more like what I drew on paper. So it matches up. Okay, now that we can see the scatter plot, we want to draw the line of best fit. So what we're going to do is add, so we're going to go to that plus symbol again, and we're going to add an expression. So for this expression, we want to type in y1, and you could type this in with a keyboard, but what I did is you can just highlight y1 from the table, Control C, Control V. So you can just copy and paste it from the table. And then we want this kind of squiggle, which is on your keyboard. So that, Again, there's a keyboard within Desmos. You can show the keypad and you can find all of these symbols on there too for inputting this. I will have M and then X1, which I am also just going to copy and paste from the table. So Control C, Control V, and then plus B. And there's the line. So I can see my line of best fit here. I wasn't too far off when I drew it by hand. I think I was going exactly through that point right there. So we can see our line, we can see the dots. What we want to grab from this is our line of best fit, and what we want to grab is the slope and that intercept right there. So what I'm going to do is write those two values onto my paper. So we found our line of best fit is the line where the slope is 0.4761. I'm going to round them to 4 decimal places because when we start plugging in, we want to be as accurate as possible. And then the intercept is negative 926.615. All right, so now what we have is if we want to make predictions, which we're going to do in these next steps here, is that now we can plug in instead of just eyeballing it and looking at the graph and seeing, okay, 2005, where's that landing about? We can actually calculate it by plugging it into this function right here. So let's do that. If it's 2005, so in some examples we talked about like plugging in time in terms of years after something. Notice that our X values are based on the full year. We didn't adjust it in terms of like years after 1990. If we did that, then we would have plugged in 0, 2, 4, so on and so forth. But because we plugged in the whole years into the table, we're going to plug in the entire year for X. So what this will look like is 0.4761 times 2005 minus 926.615. And then we'll just plug that into a calculator, which I'll do on the side here. And that should be 27.97. So what we have here is in 2005, and what we need to be careful of is that this isn't an observed value, this is an expected value. We're making predictions here. So in 2005, we expect, and that should be in the wording of our answer, about 27.97% of people 25 and older to be college graduates. So that would be interpolation because we are estimating within our domain. So it's that if I look at my table, I can visualize where 2005 is landing. I can see the values around it. I just need to estimate what the actual output would be. Now we're going to do the same thing, but for 2020, which is way off the table. And as I talked about in the video before, we want to be careful with this value because we're doing extrapolation, which goes beyond the bounds of our data, and we don't know what the trends are around it and what things could have changed this trend for percentage of college graduates. But we can still plug in, excuse me, so we'll have 0.4761 times 2020 minus 926.615. So we can end up with a value, we can make a sentence for it, but we want to be careful because it's extrapolation. So we get 35.11. So in 2020, we expect about 35.11% of people 25 or older to be college graduates. but this value is from extrapolation. We want to include that with this idea that we expect that value, but we could be completely off in terms of a prediction because it's beyond our data set.